Okay, so when we left off, we had marked out all the spars and marked out where our battery is going to go, where our motor cutout is going to be. Both top and bottom, all the spars are in. This baby is nice and stiff. So at this point is when I would typically sand it. So I just use a sanding block with like 200 grit. It's a foam one. And just give it a nice little light sand so the foam goes from being hard, that hard surface, to just a nice soft smooth surface. So just to give it a little sand, nice light sand, and then you're good to go. Alright, so let's cut out our battery box. I've measured the battery box to accommodate a Tattoo 3700. So most 3300 packs will probably fit. A 4000 pack might be a little bit large for this. 3700 Tattoo pack is like the perfect pack for this, especially with the motor that we're going to be running and ESC. So I'm going to cut this out, but I'm going to do this a little bit unique. I'm going to cut it all the way through. Then I'm going to make a ABS bottom plate that'll be sunk in to be flush. So I'll fashion that so the battery will just have Velcro inside, and just drop it in there, press fit in. It'll be nice and flush, maybe just a little bit sticking out, but nice and flush, and it'll stay in there perfectly. It'll be a really nice setup. So let's get to cutting. So I'll just use the large knife and cut in. Nothing special about cutting in on this. I'll show you on the bottom side how I'm going to do a special little layer, a little step. But I'm going to cut all the way through, trying to get this blade vertical. And then what I'll do is I push this knife all the way through, and then I'll like guide it till I can get like a 90-degree edge. I can see exactly where the corners are. And I'll bring it out and I'll do the other side. Stick our knife in till we get through, and then I'll run it in till I get all the way over to the other edge, and you'll be able to see exactly where it goes. Okay, so that side, and it makes a nice clean cut on the bottom. All the way through, and then try to make a nice clean cut. You can see the foam staying down. It's a nice clean cut. Really nothing special about this. Just be careful not to cut too much out. And sometimes you might even want to preserve the plug, because there's a couple of techniques that guys may use where you can take this plug that we're going to create, and after you're done, you can trim the plug so that, and then glue it back in and have a nice clean pocket, a nice clean foam bottom instead of like an ABS plastic one like I'm gonna do. I like the ABS though, because then you can, it's stronger than the foam. You can stick stuff to it without having to put layers of glue on the foam to get it to, you know, put adhesive of any type on it. I just like using the ABS. And I just buy thin ABS sheet from like McMaster Car, a great source for getting all kinds of materials for plastics and foams and screws and that kind of thing. All right, so this should be our last cut. Try to line that up so that you're not overcutting it. And as you can see that nice plug comes out. And like I was mentioning, you can take this, and with the hobby knife, you can trim this so it's a nice small, even cut. And then what you do is you just put this back in with a little glue, and you'd have a bottom floor that's nice and clean. It looks really nice when you do it, but I don't choose to do that. So we're going to set that aside. So now what we're going to do is we're going to make a little shelf for our ABS plastic to go in, our plastic floor to go in. But I'm going to use this knife instead. And what I'm going to do is I'm going to overlap just by about 1/8 of an inch all the way down. And I'm just going to eyeball it. And I set my hobby knife just to like the first click out, because I don't want this to be real deep. I want it to be kind of shallow because we're just making enough to put in the plastic. And I'll just run this right in line with the line that I have here already. And I'm just trying not to go too deep, and I'm trying to make a nice smooth cut. And I use the actual holder. The holder will sink into a point and it'll stop. I just use that as my depth and just trace that all the way up. And do the other side. And this will come out really nice when it's all done. You'll hardly be able to tell. All right, so now comes the trickier part. I usually lengthen the blade because I need to go in at an angle to get in here and actually make this cut. So I'm going to go in about the same depth that I have this on this outside mark, so about 1/8 of an inch or so. I'm going to go in, and then I'm just going to slightly run this along while watching my edge. And I'm going to follow this the whole way down. So once I get to that point, I need to actually come to the other side and meet up with it. And it doesn't have to be perfect. You'll find that this comes out pretty quick and easy. But you just want to follow your way around and make this little step. When you get the points like this, you can also use it kind of like a saw blade and chop in a little. All right. And the last one. Nice sharp blade is what you need. That way it just flows along here, just like this. All right, once you make that cut, now you can just pluck out the area that you just cut away. And if I get this close to the camera, you'll be able to see the step that I made. See, it has a nice little step all the way around. So we'll be adding glue there, put our ABS in, and you'll have a nice little bottom tray, and your battery will squeeze right in here real nice. All right, so now that we got that part ready and done, I'm going to cut out for the motor here. This is the motor mount we're going to be using. It's just made by Sweep Wings. This is their small mount. You can buy this on their website. It's about $14 or so. It's a fantastic mount. You can mount both 22 size motors, which is what we're going to be using, a 2217, or you can use a 28 size motor, like a 2814 that you'll sometimes see. That might be a little bit too much motor for this wing, but the motor mount will accommodate it. So if you feel like experimenting, go ahead and go for it. But with the motor combination and battery that we're choosing here, this wing is easily capable of 110 miles an hour or so. And for racing, since it's a race wing, that's more than enough to handle any race course out there and be very competitive. So, as you can see here, I'm going to be sliding this motor mount in just like this. And you see that I've marked out an area here for where the motor is going to actually sit in. But right now it butts into it. So I need to cut away a layer down in here so that this will slide in and fit in there nice and neat. So we're going to We're going to cut in, and then we're going to slice in to make a little step there. I'm going to go down about, you can see I marked it here. It's maybe about a 1/4 inch down, maybe a little bit more. But I'm going to slice in. And I'm just trying not to, be sure not to go too deep. You don't want to cut all the way through. Then you'll have to do a foam repair. I just want to cut in deep enough that I can make a nice little step down. Get a nice straight edge on everything. And then lengthen your blade. And you're going to slice in at an angle here. And you're going to go in stages. So I'm going to slice through a little. And then go back and slice in a little deeper. Until I get this whole shelf cut out. And try to be careful. And I'm trying to do it at a 90-degree angle. Or parallel to the tabletop. So that I get a nice straight shelf. I could also use a Dremel and just route this out, but we're going to do it with the blade here. And another trick I'll do is, since it'll be hard to get this all the way in there, I'm just going to cut away some of what I've done so far. And then just pluck this foam out, and then go in and do the other parts. All right? Then we're going to go in a little bit and do the rest of it. Just be careful, because this part is a little bit tedious. And you can continue to take out layers if you like, if it might make it easier. So I'll go in and cut out another layer. Oops. There. And we'll take one last layer shot here. And I'm just trying to be very careful not to damage the foam around it. I just want to pull out these plugs and be done with it. Yep, there we go. Get this so it's nice and neat. All right, good. So there you go. It's a nice little step down that you can see in there. Nice and flush, nice and smooth. Comes out really nice with the razor blade. So now the motor will slide in just like that. See how nice that fits? And we'll be able to rotate really nice. It'll go right in, butted up against the back, that back wall of the motor area. And what we'll do when we go to mount this, we'll do it a little bit later, but I'm going to take the motor out. And I'm going to take my Dremel and a sanding wheel, and I'm going to rough up all the aluminum so that it really grips when we go to mount this on. I'm probably going to mount this I'll probably mount this and then laminate and cut the laminate around it. But some may choose to put the lam all the way on and then put the motor mount. I usually don't do that. I usually like to have major structural pieces direct to foam. You can do laminate and then put it on, but there's a technique that I'll use. I'll usually use glue like welders. I like to build with welder's glue. So what I'll do is I'll mark this out, and I'll take and put welder's glue all in this area, like a nice layer of it. Then I will laminate the wing, and then take a Dremel sanding wheel again and sand the laminate to take that clear sheen off of it, to make it rough. but not cut all the way through it. Just make it rough. Then when you glue it, now you have a good base where it's going to be glue to lamb to glue to metal. That works really good too. So you can choose to do it a couple of different ways. I think I'm going to glue it directly to the foam though and put the lamb on after. It should still come out really nice and clean. All right, so at this point we've got these items in place. Now I'm going to I need to trim away some here in the back, but depending on what motor and prop you're going to use and power plant, you're going to have to decide how much you want to cut away. So I know I'm going to be running a 6-inch prop with this motor. I really can't go up anymore. I can just go up in pitch or down in pitch in the prop. But I'm going to be typically using a 6x4 maybe. I might even go down depending on the kV. If I go a 2300 or a 2500 kV, I may go down to a 5.25 prop, but at the most it's going to be 6. So I put a 6-inch prop on here, and I want to kind of get an idea of how far out this prop goes. Let me grab a pen. And I'm going to mark where the prop actually ends. And what we're using is a 2300 motor with a collet spinner on it. So I just purchased a nice collet spinner for it and put that on, and I can measure exactly where I want to place it and then mark where my prop is. So now what I'll do is I'll add some taper to it with the ruler. And I have to decide, do I want to go out a little and then come back, or do I want to just make a nice slant? I'm actually going to go out some, probably the width of the prop, and then cut a little taper to it. That way I don't have this really sharp angle and lose some Elevon. I'm going to try to maintain as much Elevon as I can. So I'm going to actually add, let's say, a 1/2 inch. All right, we're going to add a 1/2 inch to each side. And with that mark, I'm going to get an idea of where I want it to give a little clearance for the prop. You want to give at least a 1/4 inch clearance or so. That way you don't have to worry about it. So I'm going to mark, and then I'm going to measure it just so I can make it exactly the same on the other side. And right now my measurement is 1 3/4. So we'll go 1 3/4 inch over to this side. And mark. All right, so with that mark, I can actually take our hobby knife. Actually, let's make this cut first. We're going to cut in. And I'm using this straight edge of the back of the motor area as my guide. And I'm going to cut in. And then we're just going to trim away this area here using our marks. And try to cut it a straight angle down if you can. It really doesn't matter if you have any kind of angle, but try to make it straight. It looks nice and neat that way. And there's one side. And here's our other side. Okay, so there we go. Nice and neat. So now our motor should fit in there beautifully now. Fits in, nice clearance for our prop, as you can see. All right, so coming along nicely. Okay, at this point, we've done all of our cutouts. We've got the motor area done. We have the prop area done. And now that I have this taper cut back here, I know exactly how long my elevons need to be and what angle I need to make these cuts at. So now we're just going to do our elevons. So we have our elevon stock. And I know a lot of people have questions about how do I know what's top and what's bottom. All right. I usually will look down the edge of it, and you should see with the bottom flat, you should see a nice 90-degree angle. The top part should taper off and down, but this should be 90 degrees to the bottom. If you have it upside down, you'll notice that when the bottom is flat, it should taper off a little bit, leaning back, and you know it's not right. Another way to check is, let me move this out of the way. Say you have these down like this. If you butt them up against each other, you see a nice gap there. That gap there should be virtually no gap when you have them correct. So let me flip them. If you notice, see how that gap is virtually gone? That way I know that I have a 90-degree angle here to the countertop. So I know that these are the tops of my elevons. And I do a little thing where I'll mark them. I'll just go put a little T on them and mark them so I know that these are the tops and I won't get confused. So now I'm just going to set one of these aside. I'll grab another one. And I'm going to actually butt this up against here. And what's nice about this wing is a lot of wings will have a slant or a taper to this rear edge here. TBRC has made this a actual straight edge so that your Elevon will butt up against it. Now you might say, okay, well now when it goes to hinge, it's just going to hit against this flat area. Well, what I'm going to do is we're going to be tapering all this area. Even though it's already got a taper to it, I'm actually going to be trimming and sanding this in order to make a nice rounded edge to it. And that way it'll be able to rotate once this is mounted up, and it'll be really nice. It'll take a little more work than you might be used to on some other wings, but that's how I like to do it, and it comes out good on this wing. All right, so what I do is I'll set this somewhere in the length of this. Doesn't matter. You can go to the edge or somewhere else. It doesn't matter. I usually just put it somewhere square, and I'll just get rid of the parts that I cut off. And I'll take my straight edge and I'll match this taper that I've cut in for the prop clearance while holding this together. Hold that together, and I'll mark it with my marker. All right. Then at this end, what I do is I can decide whether I want it to go cut away like at a straight angle or cut it straight in line with the outside edge of the wing. I'm going to cut it straight with the outside edge. That gives me a nice, neat cut. So what I do is I line it up with the outside edge of the wing while holding this together. Outside edge of the wing, but I don't want to go all the way to the edge. I want to leave a little bit of gap, because once the winglet's on here, the winglet could get hit, it could get dropped in the car, whatever. You don't want this Elevon through its motion to rub up against the winglet. So I usually go in maybe about, I don't know, I'd say 1/8 of an inch, maybe a little bit less, and I will mark that with my ruler. All right, so now I'll be able to cut that. And mind you, even though you might think all wings are the same, it's funny, this might be a little bit shorter than this one. So I usually don't go and mark these over each other. I will go and make this one's going to be the left side, and I'll go back and I'll do it on the bottom. I'll usually mark this left. And then I'll go and I'll build the one for the right side. So again, we'll butt this up against the edge. We know that's our top because it's marked. And I'll follow this taper line. And then out here, I'll mark a straight line going in 1/8 of an inch. And mark my line here for the outside edge. Okay, and mark this one right. All right, so now I'm going to show you how I cut these. I just do it old school style. You can do this cut any way you like. I just take an old 2x4 and a regular straight saw, and I will do my trim this way. Just marking, just going right down my line. Just give it a nice little pull. These will be sanded after, so don't worry that it's going to be like a rough edge or anything. We'll be completely sanding these Elevons when we're done. You just want to get a nice, good cut on these so that it's nice and even. Good. There's our one. And here's our last cut. So now we have one more thing to do. We'll use that and get some of this sawdust out. All right, here's a topic of conversation, and you'll hear varying opinions about it. But what about putting a taper on the Elevons? Do I leave my Elevons completely straight? Or do I cut a little taper in them like you'll see on a lot of Elevons? What's the difference, you might ask? There really isn't much difference. But the theory is, with the wing generally flies about this much on the outside tips of the wing. That's where most of the lift is and where most of the flight characteristic is for when you want to do rolls and just, you know, the dynamics of the wing. So is there a reason why I need to have anything towards this inner part on the Elevon? The answer is no. If I'm doing most of my flying out here, this is where I want the majority of my Elevon. Anything in here is just going to be extra, and it'll add to the authority of the way that the wing will fly, how hard it will make turns or how hard it will pull, the authority on, you know, the feel of which the wing will fly at. However, we run into another situation where wings are typically tail heavy by design. So anything you can do to get that weight forward is going to benefit you. So typically that's why we'll trim off some of this area back here to take a little weight off of the Elevons. It's not going to hurt the flight performance because, again, it's flying at the tips. And it'll still have the authority because we're going to keep that. But how much do we trim away? How do I make that cut? I usually will go on a wing that's 36 inches like this, or 38 inches I believe this wing is. I'll usually go 8 or 9 inches from where the tip is. All right, so I will typically go 8 or 9 inches from the tip. And I'm going to look at this. There's no exact science to this. It's just I go by eyeball. Everybody does it different. Some guys will trim off on the tips and round them and, you know, do all kinds of maybe triple cuts or something. I don't do that. I just do a single cut. So if I go out 9 inches is going to bring us to right there. 8 inches is going to bring us to right there. let's give as much as possible. So we're going to go 9 inches. So 9 inches from the tip inboard, we're going to make a mark. Nine inches from the tip, we'll make a mark. And then I'll go 1 inch back from this edge. So I'll mark let's go back 1 inch. So I'll go back 1 inch and make a mark. So now we'll mark these, and I'll be cutting this with a hobby knife. This is going to be our taper. And after I do this, these again might not be exactly identical, but we're going to make them identical once we sand them. So I'll get my block again, something soft, and I will just mark this line and run it up. Trying to keep this at 90 degrees so it's a straight vertical. There's one. And there's 2. So now that we've got that, wing is right side up. This is what our Elevons are going to look like. There's our left one. There's our right one with a nice pretty taper. There you go. And we'll be sanding these up and making them all nice and pretty. And at that point, we'll be pretty much ready to do our prep for the wing and do any paint. If you choose to paint it, we'll be using a wrap. We're going to do a wrap around the entire thing. Okay, at this point, the one last thing I want to do is I'm going to mark out where I'm going to put my servos. Now, I'm probably going to cut pockets to put these in because I like to mount my servos so they're laying flat, not vertical like this. I want to lay them down flat. Now, here's another topic of conversation. Where do I put my servos? You'll see some people that'll put their servos so that they're in line with it or 90 degrees to this edge so that you have even torque or that you have a straight throw to your Elevon. Some guys will move them way out on the wingtips so that you can put the servo horn here in the center of the arm. Fantastic. However, now that you've moved the servo all the way out to that wingtip or near the wingtip, you're adding weight to the wingtip as well as you're putting weight behind the CG point of the wing. And the CG point of this wing is roughly 6 3/4 inches from the tip of the nose here, the blunt section. So it's going to be somewhere where these spars are. I haven't marked it yet, but it's going to be somewhere in this area. So anything that's behind it, you want, again, you don't want they're naturally tail heavy, so you want to bring as much weight forward as possible. And if you can, bring many things towards the center of the airframe so that it has a nice crisp roll axis as well. The center of gravity becomes centered on the wing instead of having weight that's out in the end. These don't weigh much, but still, I'd rather have these up in here. And where I'm choosing to put these is I'm going to mount them somewhere as far forward as I can, and I'm going to try to catch it right in this little pocket in between where the spars are. All right. Now, I want to be careful not to move it too far forward, because if I move it too far forward, I might catch the curve over the top of the wing, the airfoil. So I'm going to try to put it back because I want that rod to give a nice straight throw back to where the Elevon is. So I'm probably going to put it back here, but it's going to be, again, in front of the CG mark. So it's actually going to keep the weight towards the nose. All right, so I want to put it as far outboard as I can as well, or pretty good outboard. And the reason being is I want to, even though I won't be able to catch the Elevon in the center of its width, so I can get an even throw or torque on it, I'm going to try to move it out as far as I can so that I can get as much towards the center as I possibly can. So what I'm going to do is I'm thinking I'm going to mount it probably somewhere right in here. And if you notice, I've put the actual servo horn location towards the rear, not towards the front. Not towards the front, I'm putting it towards the rear. That way I can keep this control rod as short as possible and actually have it have its stiffness, maintain as much stiffness as I can. So we're going to mount it right around here, and I'm going to choose to put it right in line with where these spars cross over each other. So the outside edge of the servo is going to go right to where that spot is, and I'm going to hold that position and I'm going to mark it. And by marking it and putting it in this location, let's take a straight edge and find out exactly where our control horn is going to land. If I go straight back 90 degrees, you can see that our control horn is going to land in a pretty good part of the Elevon. It's not going to be somewhere over here. It's going to be somewhere straight out here. And we're going to run our link straight. Now, this is another thing that you'll see on some wings. Guys will mount them so that their control rods, or they'll twist the servo and have the control rod go to a spot like this so that it gets direct straight throw with this rear edge of the wing. Now, while that's really good, it adds good torque to it, to the throw of the servo. It doesn't give it non-linear throw like I'm going to be doing by having it like this. So that's going to be actually on a straight, and it's going to give an angled throw to the Elevon. Now, should I worry about it? I've never worried about it because I think the pluses work in our favor more than the minuses. The only minus would be that you're not getting maximum torque because you're having a non-linear angle to how the control rod goes. But I like to do it like this. One, because now your control rod is in line with airflow, so you have less drag over your control links. And two, you can get the servo mounted way in more and also and stay towards our center of gravity, as well as the control throws on these wings are so small that we might only have about that much up and that much down. So when we talk about torque, it's really not going to work negatively against us, at least not that much, because we have such little throw on these wings. If we had 3D throw like a 3D stunt airplane where you might have control throws that are like this, certainly it would be much better to have it to where you can get the maximum torque from the servo. But we're not going to worry about that. So now we've got the one servo marked. I'm going to get an idea of where I have it here. And I'm going to mark it on the same, I'm going to put it over here on the same side and try to catch my marks the same as I have on the other side. So again, I'm going to look for the crossover of my spar. I'm going to bring it back as far as I can without bumping into this spar. I want to give myself a little bit of room. And I can use this nice edge as a nice 90-degree mark for me. And I'm going to mark this servo. Okay, there we go. So my servos are marked now. And for this wing, it's good to use a good 14-gram servo. These are Emax. They seem to work okay. I tend to like Hobby King. They sell a servo called the Hextronic MG14. It's a Metal Gear 14 gram, really good servo, and they actually are very inexpensive, so I'll probably be using those in there. They're exact same size as these Emax, so for my measurement purpose, I'll just mark it with these, and we'll be putting in the other servos at the time we do the installation. Now, I'm going to cut these pockets such that they're a pretty tight fit. I don't want to cut them smaller than what they are going to be, what these marks are. And I want to show you my technique at which I do that. So let me grab a few tools and I'll be right back. Okay, we're going to actually cut out for our servos. I use a little technique that I've seen others do somewhat like this. I do it slightly different, but this works really nice, and it's great for cutting pockets like this, pockets like this, pockets for servos. Works really good. What we'll be doing is I'm going to slice in, and again, I want it to be a tight fit. So I'm not going to go on my mark. I'm going to go inside of where my mark is, so I get a nice tight fit. Now I also need to make sure that I leave room for when the servo horn is on here. So I'll need to cut out a little bit of extra area out here just to make sure that I have clearance for when I put the arm on and it moves back and forth. But the main body we're going to cut out. So what I'm going to do is I'm going to cut in, and I'm going to go down to a depth that I feel, this is all freehand, to a depth that's going to be close to the depth of what the servo is. All right. And then I'm going to be doing the old foam plucking method. So how I do it is I'll cut out the outside. And I'll get in there and get the dimensions on the inside. All right, so I'll cut our outside part, and then I'll just make slices, so layers here. We'll just slice this up so that I can go and pluck this out a lot easier than one big chunk. We'll do a few slithers of smaller chunks. All right, and then I just take a piece of needle nose pliers and I pluck out my foam. Now, you could choose to do only this part and just keep plucking till you get everything kind of where you want it, but I like using the Dremel, and you'll see why when I'm done. And I just want it to be close to the depth that I want, and the rest we're going to take out with the Dremel. Now, as you can see here, it's still really rough inside, but the servo will fit in there nice and snug. Yep, fits in there nice and snug, and we'll do the cutout out here after. But it fits in there nice and snug, but now I need to match the depth that I need. And actually, let me cut out for this now. I'll leave that in its place. And we'll go straight out and give ourselves a little bit of room here. This will clear the servo horn. All right, and again, we'll just take some slithers out. All right, so still rough in there. I'm going to take the Dremel, and what I use is, I'm not sure which bit this is, but I think it's for tile cutting, but it's just a real grinder kind of bit. But this works good for taking the foam away without really damaging the foam around it. And you can use it just like a pencil. So I'll set it on kind of a low setting. That way it doesn't really get into it, and if you make a mistake, it's not going to eat up some foam where you don't want it to. And I will just go back and forth, just like a little pencil, and take out all those rough spots. And just go down to a depth that'll be the depth of the servo. And then I'll just go across, back and forth, eating out this foam. And what's nice is, now that you've cut this with a razor, it gives a nice clean edge on that, on all the sides around it. You're just smoothing out the bottom so you have a nice smoother, flat surface cut with the Dremel on the bottom. I think I'm going to need it a little deeper than I have it now, so again, just go a little bit deeper than what you have already so you get it the depth that you want. But this way you don't have to cut all the way through the foam. And then glue foam back in. You can just trim in like this. So let's do a fit. Look at that. See? Nice and flush. That's how our servo's going to go in. Nice and flush like that. And we have clearance for when the servo arm's on there so that it can go through its range of motion. Alright? So there's one, and what we'll do when we're ready, I'm going to lamb over this and then I'll drop this in. I won't put this in. Well, you could. There's no reason why you can't just glue this servo in and then run your laminate over all of this. That can work also. I'll decide at the time which one I'm going to do, but I just want to get these pockets cut out, but we're good to go.